Hello everyone, I am Shantanu Wairagade, a student from Engineering Physics 3rd year, and I would be talking about the usage of sensors and transducers in F1 racing. I would be talking about accelerometer, temperature sensors, heat sensitive stickers, pitot tube, coil probe, damper potentiometer, monitoring sensor, and load cells. And in the end, I would be talking about how they utilize this information to their advantage. Let's first talk about F1. Formula One, also known as F1 racing, is the pinnacle of motorsport characterized by high speed, open wheel racing cars competing in a series of Grand Prix events held on circuits around the world. F1 is governed by the Federation Internationale des Automobiles (FIA) and features teams representing manufacturers and privateers, each with two drivers. There are 10 teams, 20 drivers, which means each team has two drivers on the grid. I would like to describe it as 2 hours of pure adrenaline. Winning strategy includes when to change tires and which tires to put on, and many more things like these. I would be talking about the strategy later in the PPT. First, accelerometer. An accelerometer sensor is a tool that measures the acceleration of any body or object in its instantaneous rest frame. It is not a coordinate acceleration. Accelerometer sensors are used in many ways, such as in many electronic devices, smartphones, and wearable devices, etc. In this particular case, it measures the g-force created during the turning and braking, which is very important for the F1. Here is a link for the crash which happened in 2021 Silverstone, England during British Grand Prix, and the driver victim for this was Max Verstappen. F1 drivers have accelerometer in their earpieces so that accurate data can be gathered on the forces acting on their driver, which is particularly important after a crash. The report tells that Max experienced a force of 51 Gs acting on his body. That's a lot of force for a human being. F1 drivers are trained for that. They have an impeccable neck strength to drive such high speed cars. Now let's talk about the temperature sensors. This is a particularly interesting design. It is known as 10x's RI-NXC-F1. It is an infrared surface temperature sensor that reads maximum temperature of 200 degrees and can operate over distance of up to 950 mm. It is extensively used in F1 by over 90% of the grid and combines perfect accuracy at 200 degrees Celsius, as I have discussed. Um, uh, it has a great temperature compensation, makes it ideal solution for measuring temperature across the whole surface of the tires, and even in the extreme condition. The sensor is primarily for use in open wheel applications, which is in F1, and can be mounted on the leading edge of the side pods or the wing mirrors. We are also wing mirrors can be also called as the rear view mirrors. Then we have the sensitive stickers. Probably the simplest used in F1, a heat sensitive sticker is literally an sticker that the mechanic places at the location where it is tough to install the previous one sensors. Another form of it is also another form of thermal sensor. The sticker reacts differently at different temperature and has an incremental indicator that changes color when a certain temperature is reached. In this picture, McLaren has installed a few of these stickers on the brake drum to measure the surface temperature. When a car comes back in the pit, the mechanics and engineers look at the stickers and note down the temperature readings. If the temperature reading is too high, it indicates that it's not enough air is flowing into the brake ducts, and either the aerodynamic setup of the front wing has to be changed or the shape of the brake duct assembly has to be redesigned to allow better cooling. Conversely, if the temperature indication on the heat sticker is too low, the brake is not being used to its full potential and may have to be investigated. Next, we will talk about the pitted tube. This measure, this pitted tubes are most commonly used in aeroplanes, where they are used as the speedometers. In F1 cars, the pitted tube measures the speed of the wind flowing over the top of the car. This measurement is affected by the wind speed, wind direction, speed of the car, and also the position of the pitted tube on the car. Engineers can use pitot tube in understanding if the movement of the air over the car resembles this simulation results. If it doesn't changes can if it doesn't changes can be made to the cars to get the desired aerodynamic balance. A pitot tube measures the dynamic pressure and compares it with the static pressure to give an output value. Here we will talk about the Kyle probe. It is also variation of the pitot tube which is shrouded around it to prevent the inaccuracies from the yaw of the cars. One of the most common sights during F1 practice session is the car running with an array of these Kyle probes. As shown in the picture, the array is formed by the multiple Kyle probes and the pressure sensors is mounted away from the array downstream of the car. This allows a number of Kyle probes to be installed in close proximity and form an array. The team uses data from these arrays and assembles the air pressure around the sensitive areas during CFD tools. During practice session, teams can either adjust the front wing angles and try an entirely new wing to change the airflow characteristics over the car and try to get as close as possible to the simulated value. Now we will talk about the damper potentiometers. These are very simple devices. It measures the spring compression and chassis roll response. As long as we know the mathematical relation between each part of the suspension, it doesn't matter where the suspension is placed. Now we here are multiple monitoring sensors which send signal of data about the health of the car system, like engine health sensors, which includes engine temperature sensors, um, oil pressure sensor, oil temperature sensors, coolant temperature sensors. Then comes the electronic and control system sensors, which include the engine control unit, the wheel speed sensors, gear position sensors, brake pressure sensors, and much more. Then we have brake monitoring sensors, which monitors the wear, pressure, and temperature of the brakes. Then we have suspension and chassis sensors. Then we have the tire monitoring sensors, which tells us about the temperature and pressure in the tire, and about the fuel, about the level of the fuel, what's the flow of the fuel, what the kind of pressure the fuel is creating on the car. Then we have hydraulic systems, which then we have the safety sensors, like what's about the driver's health and all. If there's fire or any smoke detection is there, it tells about that it tells about the inner safety sensors. Then we have also one of the basic things which we have learned in the class about the load cells. They are employed to measure the force acting on specific component such as brakes, pedals, throttle pedals, and suspension elements. By analyzing the load cell data, engineers can assess driver input, evaluate the distribution of forces across different components, and optimize setup parameters for improvement, performances, and consistency. Now we will talk about how they utilize this information, because we are gathering this kind of information, so we have to utilize it to the fullest to win, because the aim of F1 is to win, get maximum points and win the driver championships and constructor championship. The more higher you ranked in these championship, the more money you get. The more better car you can design for the future prospects. Like F1 teams employ a multi-phase approach to win races, integrating various strategies and tactics aimed at maximizing performance. Here are some of the key strategies commonly employed by F1 teams, like car development, which I talked about. Continuous improvement of the car designs and performance is fundamental. Team invest heavily in research, development, and innovation to enhance aerodynamic, chassis, power units, and other technical aspects of the car. Then there's race strategy. Developing effective race strategies involve analyzing data such as the tire degradation, fuel consumption, weather condition, and track layouts. Like in this image, we are talking about the tire components. Basically, in F1, there are three tires: the C1, C3, C5. C5 are the soft tires, C3 are the mediums, and C1 is the hard tires. As you can see, C1 has the longest time, they can last longer, but this performance, also we can call it as speed, they're relatively slow, but they have a low degradation rate. Medium C3 is a medium tire, and C5, which are very quick, but they will degrade very quickly. So here we have seen a crossover point. Like if a person is using C5 and another person is using C3. So we can judge like when the C5 will be fast and when the C3 will be fast according to the lap timings and the how much the tire has been on the circuit. Then we have the team strategy pit stops, when to change tires, which I've talked about. Like if you change the tire, it takes a little bit amount of time, like to enter the pit and get out. So we have to manage it all without by calculating how the other team are responding to our pit stop and all. Then we have tire management, like we have talked. Then they have driver performance. F1 team rely on skilled drivers to extract maximum performance from the cars. Drivers play a significant role in executing race strategies, managing tire wears, and navigating traffic and making split-second decisions during the race, like whether to overtake or not, whether to maintain the tire. Like they constantly ask uh, to the pit wall about what to do, like during this such situation, like should they maintain their tires, should they go all in attack, and because after going in all in attack the tires will degrade faster, and if they are behind a particular car, the dust coming out from that car also degrades the tire, and that's critical in such situations. Here is a photo of the pit wall. Like here are all the technicians, strategists, and particularly in this picture you can see the Red Bull pit wall, and this is the Christian Horner, the team principal of Red Bull. Like the race strategies in F1 comprise a variety of approach aiming to optimize the result. The qualifying strategies, like first we have the practice race where they gather all the information, like all these sensors and transducers are used, so we can gather information about how's the weather, how's the wind flow, what time kind of temperature we are getting, is it helping our car, and then we will modify it. And then we have the qualifying race in which we have to set the grid, so the goal is to get the fastest lap and we will be in the top of the grid. And there comes times the defensive strategies, defending position against the attacking rivals require strategic driving and positioning on the tracks. Driver may employ defensive lines, blocking maneuvers, and strategic use of DRS, also known as the drag reduction systems, which are used in help to overtakes and attempt to it's basically used to overtake, because it gives us better speed and all. Then there are other strategies like safety cars and all, then weather strategy. These all things are quite important in F1s, but like the Kyle probe which I've talked about, it gives a perfect idea of the aerodynamics which the car have, what changes we can do to make it more aerodynamic for the main race. And this is the one of the greatest shot taken none other than at the Indian GP Grand Prix in 2013 at the Bhuj International Circuit, Greater Noida, Uttar Pradesh, India only. In conclusion, I would like to conclude my presentation by quoting the greatest driver, Michael Schumacher. It always believed that you should never ever give up, uh, and you should always be fighting even if there is slightest chance. In conclusion, sensors and transducers play a pivotal role in gathering real-time data, providing insights into the intricate dynamics of the F1 racing cars and enable engineers to make information decisions to enhance performance, reliability, and safety. We dived into intricate strategies teams employ to gain an competitive edge, the thrilling race that captivates the million of fans worldwide, and enduring the legacy of this remarkable sport. From the historic circuits of Europe to the vibrant venue of the globe, F1 continues to inspire and enthrall audiences with its blend of speed, precision, and drama. I invite you to dive deeper into the world of F1 to witness the first hand, the excitement of the races, the innovation of the technology, and the camaraderie of the fans. Together, let us celebrate the extraordinary spectacle that is F1 racing. And I also hope that it will come back soon in the India. Thank you.